Okay, hello everyone. In our last class, we have been discussed inverse Laplace transform of second shifting property and corresponding numericals. In our today class, we are going to discuss inverse Laplace transform by convolution or convolution theorem. Okay, so let's start. By this theorem, Laplace transform of convolution of two functions f1t and f2t. f1 and f2 both are variable of t. Okay, Laplace transform of convolution of two functions. This symbol is represents the convolution of these two functions is equal to Laplace transform of convolution of two functions also can be represented as 0 to t f1 x is another variable into f2 t minus x dx. So this f1t convoluted with f2t or f2t convoluted with f1t also will be this value. The proof here we are not considering the proof how this will be this proof you can found in your mathematics syllabus. So convolution of two functions also can be written as this one f1 x is the another variable instead of t, f2 t minus x 0 to t integration with respect to dx will be equal to f1s into f2s, capital F1s into capital F2s. Here inverse Laplace transform of capital F1s equal to F1t, inverse Laplace transform of capital F2s equal to F2t. Okay, so hence inverse Laplace transform of this one will be equal to this much, or we can say this much. So inverse Laplace transform of f1 capital F1s into capital F2s will be equal to 0 to t integration f1x into f2t minus x dx. We are going to use this one to solve the numericals. The first numerical is your find inverse Laplace transform of s by a square plus 4 whole square. Okay, so this can be written as 1 by a square plus 4 into s by a square plus 4. Now consider this one is your capital F1s, this one is your capital F2s. So inverse Laplace transform of this one will be equal to 1 by 2 sine 2t, because just multiply 2 and divide 2. So 2 by a square plus 2 square is nothing but sine 2t, or 1 by 2 is there. And here s by a square plus 2 square, 4 means 2 square is nothing but cos 2t. We know that one. We are very much familiar with these two terms, 1 by a square plus 4, s by a square plus 4. Okay, by applying convolution theorem, what we can found? We can found that we have to apply the inverse Laplace transform. Whenever we are going to apply the inverse Laplace transform upon this one, f1s into f2s, f1s f2s will be equal to how much? 0 to t f1x, x is another variable, into f2 t minus x dx, t minus x. So here also same thing we have to apply, or we are going to consider inverse Laplace transform of this one will be this much, and f1t is how much? This one is your f1t. Okay, f1t, and this one is your f2t. So whenever we are going to consider convolution, this t variable it changes to x, f1x into f2 t will be t minus x dx. Okay, so here sine 2x we have to write, so 1 by 2 f1x, that means 1 by 2 sine 2x, 1 by 2 sine 2x. Here cos 2 t minus x, because f2 t minus x we have to write, cos 2 into t minus x dx, right? So here you can see this is in the form of 2 sine a into cos b. See, if I am going to multiply 2, divide 2, the denominator will be 1 by 4 taken outside. So 2 into sine a into cos b formula we have to use. So 2 into sin A into cos B, that means sin A plus B plus sin A minus B. So sin A plus B means here 2t minus 2x, 2t minus 2x plus sin A minus B. A is means 2x minus of 2t minus 2x. That means minus 2t plus 2x dx. Right. So here 2x got cancelled, and this 2x will be 4x minus 2t, and this will be sin 2t dx. 1 by 4 is there. Now we are going to consider the integration. So if I am going to consider the integration, here you can see sin 2t will be a constant whenever we are going to consider integration with respect to x. So 0 to t integration sin 2t dx means sin 2t will be a constant will be taken outside. I am going to do here sin 2t dx 0 to t, that means sin 2t will be taken outside, will be dx integration will be x 0 to t 0 to t, that means 0 to t. After that we have to put the limit, but integration will be x sin 2t. Okay, same thing it has been written x sin 2t. Now this one sin theta integration, we know that minus cos theta. So minus 1 by 4 cos 4x minus 2t. See here 4x minus 2t, in these two terms this will be attached, this term will be integrated, but this term 2t will be constant. So if we are going to consider 4x minus 2t will be another variable, okay, I will do for you. It is very easy integration 4x minus 2t integration. So consider this one as p. So dp will be how much? 4 into dx. So 1 by 4 dp will be dx. So instead of dx we have to put dp by 4. So sin t 1 by 4 sin p dp. So sin p is nothing but minus cos p 1 by 4 p is nothing but 4x minus 2t. Same thing it has been written 1 minus 1 by 4 cos 4x minus 2t. 0 to t is your limit. Now we are going to put the limit. Here you can see t. If I will put t over here, then t sin 2t. Then if I will put t over here, 4t minus 2t will be 2t. So t sin 2t minus 1 by 4 cos 4t minus 2t. Then if I will put 0 over here this term will be 0, and substituting 0 over here, this will be cos 2t, because cos is a even function. Cos minus 2t will be here I written, okay 1 by 4 cos minus 2t. Okay, now 1 by 4 t sin 2t will be there. Then this will be 1 by 4 cos 2t plus 1 by 4 cos 2t, because cos is a even function. So here cos 2t plus cos 2t minus got cancelled, when we found the answer will be 1 by 4 t sin 2t. Here I done mistake, t sin 2t. Okay, t sin t mistakenly I written, so you have to write carefully. 1 by 4 t sin 2t is the answer. Next question is this one. Find the inverse Laplace transform of 1 by s plus a into s plus b. So this can be written as 1 by s plus a into 1 by s plus b. Consider this one is your capital F1s, this one is your capital F2s, and we know that inverse Laplace transform of this one is nothing but e to the minus at, and this one e to the minus bt, that we know. Okay, again I am going to recall you that here inverse Laplace transform of 1 by s minus a equal to e to the at. If it will be plus, then it will be minus e to the minus at. So hence e to the minus 80, this one will be e to the minus 80, and this one will be e to the minus bt. Now we are going to apply convolution theorem, right? So inverse Laplace transform of f1, capital F1s into capital F2s will be equal to 0 to t f1x into f2 t minus x dx. So here this one is your so-called f1t, small f1t, and this one will be small f2t. According to convolution theorem, this will be f1x and this will be written as f2t minus x. So this will be e to the minus x into e to the minus bt minus x dx. So integration with respect to dx. Here one term will be come up, e to the minus bt is a constant taken outside of the integration 0 to t e to the power here e to the minus x. This will be e to the plus bx. Okay, so obviously e to the x if I will taken common, so b minus a into dx. Integration of this one will be e to the x into b minus a by b minus a. 0 to t is the limit, e to the minus bt. T, if I will substitute, this will e to the power t into b minus a minus e to the 0 whole divided by b minus a, and after simplify we are going to get this answer. Here you can see e to the minus e to the 0 is 1. Here one term will be e to the plus bt into e to the minus 80. Here minus bt plus bt, that means e to the 0 will become up and e to the minus 80 will be there, and this term will be multiplied with this one, means e to the minus bt. Okay, e to the minus bt. Okay, and but here I written the e to the minus bt first minus e to the minus 80 second, because denominator I just changed that from b minus a to a minus b. See, up to this much if you are going to leave your answer in your exam, no problem. Okay, now we are going to go for the next question, is that find the inverse Laplace transform of 1 by a square plus a square whole square using convolution theorem. So the given question can be written as 1 by a square plus a square into 1 by a square plus a square. We know that inverse Laplace transform of 1 by a square plus a square is nothing but 1 by a into sine 80, because inverse Laplace transform of a by a square plus a square is nothing but sine 80. But here a is not there, so we have to divide 1a multiplied with 1a, then the answer will be 1 by a sine 80. Now these two terms are same. Okay, let f1s is your 1 by a square plus a square, f2s capital F2s also 1 by a square plus a square. So inverse Laplace transform of this one will be f1t, and inverse Laplace transform of f2s will be f2t, and the answer will be for both the case answer will be 1 by a sine a t. That means here I am going to write, that is inverse Laplace transform of here this is your small f1t. Okay, inverse Laplace transform of f2s also how much, 1 by a sine 80 is nothing but small f2t, right? Now we have to apply the convolution theorem. By convolution theorem, inverse Laplace transform of f1s, capital F1s into capital F2s equal to 0 to t integration limit 0 to t f1x into f2 t minus x dx. f1t is nothing but 1 by a sine 80. So here f1x we have to write, so instead of t we have to write x. Then f2t also nothing but 1 by a sine 80, but here we have to write instead of t minus x, so 1 by a sine a t minus x. Now we are going to go for further simplification. Here you can see 1 by a square can be taken outside, can be taken outside. Then sin ax into sin a into t minus x. That means it is in the form of sin c into sin d. We know that sin c into sin d is nothing but cos, sorry, this is c, okay, c minus d, c minus d into minus cos c plus d. We know this is the basic formula. This is the basic things, that is sin c into sin d 1 by 2 cos c minus d minus cos c plus d. So here c is nothing but is your ax, d is nothing but at minus ax. So cos c minus d, ax minus at plus ax minus cos c plus d, ax plus at minus ax integration with respect to dx. Right, okay. So here you can see 1 by 2 also taken outside, 1 by 2 into a square 0 to t. Here you can see ax 2ax minus 80. Here ax got cancelled, cos 80 dx. Now 1 by 2 into a square integration of cos ax minus 80. Cos x integration is your sin x. So cos 2ax minus 80 will be 1 by 2a into sin 2ax minus 80. It's a very simple integration. Considering 2ax minus 80 will be p, blah blah, you can do it very easy. So 1 by 2 sin 2ax minus 80, and here cos 80 is a constant whenever we are going to integrate with respect to x. So only integration will be x will be come up, x into cos 80, integration limit 0 to t, 0 to t. Now we are going to put the limit carefully. So here this is 1 by 2a, 1 by 2a is there, into t will be substituted over here, sin 280 minus 80 minus here t cos 80, then minus 0 we have to put. If I will put 0, this will be sin 2a 0, so sin minus 80. So 1 by 2a minus will be there, minus 1 by 2a sin minus 80 minus here, whenever we are going to put the 0 into cos 0, 1, but here 0 will be multiplied, means will be 0. So 1 by 2a, this will be 280 minus 80 sin 80, here t cos 80, here this will be sin is the odd function, means this will be minus of sin 80, so plus 1 by 2a sin 80. So here 1 by 2a sin 80, so obviously we can find 1 by a sin 80 minus t cos 80. Now take 1 by a common from these two terms, then this will be sin 80 and this will be minus 80 cos 80. So whenever we are going to take common 1 by a, so this will be 2a cube, okay, 2a cube sin 80 minus cos 80 cos 80, okay. So this will be the answer. The next question I left for you, that you have to do by yourself. It is very easy, right? Inverse Laplace transform of 1 by s plus 2 whole square into s minus 2. The answer will be this one, e to the power 2t by 16 minus 1 by 16 e to the power minus 2t whole into 40 plus 1. So here I given somewhat hints that consider capital F1s is your 1 by s plus 2 whole square, and capital F2s is your 1 by s minus 2, right? And here you can see inverse Laplace transform of F2s will be e to the power 2t, and inverse Laplace transform of F1s will be e to the power minus 2t into t. See, 1 by a square inverse Laplace transform is only t. So s minus of minus 2 square means e to the power minus 2t will be come up using first shifting theorem. So then you have to use the convolution theorem and you can found this answer. Do by yourself, okay, do not leave it. Next question also I left for you and given somewhat hints that inverse Laplace transform you have to find out for s by s square plus 1 into s square plus 4. Here capital F1s considered as s by s square plus 1, F2s 1 by s square plus 4, and inverse Laplace transform of this one is your cos at t, inverse Laplace transform of this one is your 1 by 2 sin 2t. Then you have to apply the convolution theorem and you can find the answer. Another question, inverse Laplace transform of 1 by s into s square plus a square. The answer will be 1 by a square, 1 minus cos s at, and here also I left for you that you have to do by yourself. Inverse Laplace transform of 1 by s. Consider 1 by s is your capital F1s and 1 by a square plus a square is your capital F2s. Inverse Laplace transform of 1 by s will be 1. Inverse Laplace transform of this one will be 1 by a sin 80. Then you have to apply the convolution theorem and you can find the answer this one. Okay. Next question is that find inverse Laplace transform of 1 by s cube into a square plus 1. We have to solve it using convolution theorem. So here this can be written as 1 by s cube into 1 by s square plus 1. Consider this one is your capital F1s, this one is your capital F2s. The inverse Laplace transform of this one is nothing but t square by 2 factorial. Inverse Laplace transform of 1 by a square plus 1 is nothing but sin t. Okay. Now we are going to apply the convolution theorem. According to this theorem, inverse Laplace transform of, see, this one that implies inverse Laplace transform of capital F1s into capital F2s, okay, is equal to inverse Laplace transform of capital F1s is your capital F1s is your 1 by s cube into 1 by a square plus 1 is nothing but 0 to t fx into f of t minus x, where this one is your f1t and this one is your f2t. So using convolution theorem, so here f1t is this one. So instead of t, we have to write x square by 2 factorial. Here f2t is your sin t. So instead of sin t, we have to write sin t minus x dx. Then we have to use the integration. So 1 by 2 factorial constant taken outside, we have to apply the by parts. X square into sin t minus x dx is there. Now this integration can be done by using by parts, but here I use the Convolution function. According to Convolution delta function, I uploaded about this Convolution delta function and corresponding integration. You can found in my channel. According to this function, suppose we have two functions, gx into phi x and integration. According to this method, the integration will be gx into integration of phi x minus first derivative of gx, double derivative of phi x, then plus double derivative of first function, triple integration of second function, and so on. Okay, this method here I used to do the integration, but here gx is your first function and phi x is your second function. First and second function can be identified by using eyelet. So if I am going to compare these two functions, x and sin x, inverse logarithmic arithmetic is your first function, trigonometry is the second function. So this one is your first, this one is your second function. So according to this method, gx means here gx is your x square, phi x is your sin t minus x. So first one here I written gx into integration of this one cos t minus x. Okay, then minus derivative of this one 2x integration of this one double integration of this one, or we can say integration of this one. Okay, so here integration of this one will be minus sin t minus x. See, do not confuse. See, sin x integration is minus cos x, but how it is plus? Here you can see this is the integration with respect to dx, right? So sin x integration will be minus cos t minus x. Again, this here minus x is there, so obviously it will be plus. Wait, sin t minus x, sin t minus x integration. So t minus x considered as p, dp equal to minus dx. So this will be sin p dp, sin p minus dp. Okay, sin p integration is minus cos p minus dp. So it will be cos p dp. So p is nothing but is your t minus x. So we get the in the positive form. So cos t minus x, obviously this will be minus sin t minus x. Then third term will be derivative, double derivative of the first function. Okay, or further next derivative of this one. So this one is your 2x, next derivative will be 2, and integration of this one, or we can say that triple integration of 5x, same thing. So integration of this one minus sin t minus x will be minus cos t minus x. Now we have to put the limits 0 to t. Carefully have to put. So first we have to just simplify inside this bracket x square cos t minus x. This is minus minus plus 2x sin t minus x. This will be minus 2 cos t minus x 0 to t. Put t over here. T square. T means cos 0 will be 1 plus t. Here t means 2t. But if I will put t over here, then sin 0 will be 0. So this term will be 0. If I will put t over here, then cos 0 will be 1 minus 2 then minus we have to put 0 means here 0 means this term will be 0, this term will be 0. If I will put 0 over here, then we can find minus cos 2t, minus cos 2t, but minus is there, so it will be plus. Okay, minus, see, minus of minus cos t, that will be plus cos t. Okay, so hence the answer will be t square by 2 plus cos t minus 1. So this will be the final answer. So here we discussed around 4 to 5 questions. What are the solved using inverse Laplace transform by convolution? 1, 2, 3, 4 questions we have been solved here, and 3 questions I given to you that you have to solve. Okay, and here one important thing I want to tell to you that whatever the questions we solve by using convolution theorem, inverse Laplace transform by convolution, these questions also can be solved by using partial fraction. Okay, inverse Laplace transform using partial fraction, whatever we are going to discuss in our next class. This question, carefully you have to watch. This question can be solved by partial fraction. This question also, this question, all the questions whatever we discussed. Here each and every question you can see numerator is the function of s, denominator is also the function of s. Here numerator is the function of a constant, there is no s. Here is the same. function of constant. Here this is the question, function of s, denominator also function of s. So this type of question can be solved using partial fraction. So in your exam, suppose this question, see how to solve this question using partial fraction, that we are going to discuss in our next class. But in exam, suppose asked that you have to find out inverse Laplace transform of this one, then you can solve by using convolution theorem or by using partial fraction, what we are going to discuss in our next class. Okay, so thank you so much for watching this video. Thank you.